Hi everyone. Today I would like to talk about content analysis with similarity graphs. But before I do so, please let me introduce myself. My name is Orsolya Yaput. I hold a PhD in cognitive linguistics. I'm also the co-founder of Crow Intelligence, which is a boutique consultancy specialized in AI and NLP. I'm also the co-founder of a Manning course entitled Sentiment Analysis and Natural Language Processing for Marketing. In both ventures, my partner is Zoltán Varjú. But so much about myself. Let's focus on the talk. Let's see the aim of the presentation. First, I would like to demonstrate to you the versatility of similarity graphs. More precisely, that similarity graphs are applicable to various content analysis tasks. So you can analyze any kind of content with the help of similarity graphs. I will show you two cases, namely a text summarization task and an image analysis task. I would like to demonstrate, on the other hand, that similarity graphs fit multiple modalities. Again, in this case, I can only focus on text and images, but believe me, there are other modalities that they are good for. And finally, I would like to introduce you some practical tips on how to generate and fine-tune similarity graphs. In this way, you can get to know both the theoretical part or theoretical side and the practical side of similarity graphs. Let's see the outline of this talk. First, we will see what similarity graphs are. Then we will turn to the applicability of graphs, namely, what are they good for? And as I mentioned before, I will show you two examples. One of them is how to build similarity graphs of text, and the other is how to build similarity graphs of images. The talk will be closed by a summary. First, let's see what are similarity graphs themselves. If you have already heard the word nearest neighbor graph, then it means that you've heard a synonym of similarity graph. It is a variant of KNN. It is a KD3 or ball-tree data structure. Basically, what happens is that we find the key nearest vector, the key nearest for each vector. So basically, we draw an edge between the vector and its nearest neighbors. The weight of the edge can be the Euclidean distance. If you use Python, then the scikit-learn's neighbors can help you in this task. So much about similarity graphs themselves. Now let's see what they are good for. On the one hand, you can model any kind of structure, so the similarity of any kind of entity. In our case, we will see how they can be used for text and images, but you can also model genes with the help of similarity graphs. In this way, by modeling these entities, the connection of these entities, you can get a deeper insight to the connection of any entities. So it's important, and I would like to highlight this fact that similarity graphs are not only used for illustrational purposes, but also for highlighting some connections. So get a deeper understanding of the connections of these entities. So in this way, you can find patterns of your data. You can get to know your data better. We will see that if two or more entities are connected, it can be almost granted that these entities form two or more clusters, or they belong to the same cluster. I will show you an example for that. If you have ever felt that you got lost in a graph because this graph has hundreds of edges and nodes, then I can show you a really good practical tip how to narrow down your graph, how to navigate in a graph with the help of backbone filtering. With the help of backbone filtering, you can explore just the core connections, so the most important connections. I will show you how. Now let's see my first example, which is text analysis with the help of similarity graphs. One of our projects was about War and Peace. Our main aim was to get to know the summary of this quite longish book, and we decided that we will use graph and graph theory to make an extractive summarization or extractive summarizer, which can give us the short summary of War and Peace. There are many approaches to War and Peace, and one of them comes from Woody Allen. He said that I took a speed reading course and read War and Peace in 20 minutes. It involves Russia. Our aim was to get to know more about War and Peace, more than this sentence that it involves Russia. We will see whether we were managed to do that or not. Let's see the source of our project. As the data, we use War and Peace, so the book written by Lev Tolstoy in English, so we use the English version. You can find the whole book as a TXT file in Project Gutenberg. Then if you are familiar with NLP processes, then you can know that the first step is always data cleaning. So we got rid of the punctuation marks, and we got a pure text without punctuation marks, and we had all the characters lowercase. The next step was a pre-processing task for which we used NLTK. If again you are into NLP, you are familiar with this package, with the help of which you can do sentence tokenization and word tokenization. So we got the pure text of War and Peace with this method. As a next step, we built the graph out of the text. How? The idea itself is based on text rank, which is constructed for skipgrams. Centrality measure, usually PageRank, is used to find the most important words or phrases or sentences. It's up to you. It's your choice whether you would like to find the most important words or phrases or bigger units like sentences. We modify this idea because we know that we want to use sentences as basic units. So we use the sentence and we built the vector out of the sentence. How? Each and every word of a sentence was measured, and the average of the words was used as a vector. So it's quite easy to understand if two vectors are similar. Two vectors are similar if two sentences are similar, or if two sentences are similar, then it means that the two vectors will be similar. Basically, it means similarity of the grammatical structure, like I like tea and I like milk will be really similar sentences, so the vectors will be quite similar and they will be quite close to each other. So much about the theoretical background of building a graph out of text. If you would like to if you would like to know more about graph theory and network science for natural language processing, then I would recommend you to visit our blog, because there you can find 4 posts or 4 post series there. We wrote quite many blog posts on the topic. Let's see the steps of building, of how to build a graph out of text. So as you could see before, first you should vectorize all the sentences of your text. In our case, we used BERT, and the tool for that is a sentence transformer. So after vectorizing all your sentences, you can make a similarity graph out of the sentences. Again, if you find that you have too many vectors and you have too many connections, and if you feel that you get lost in this big wood, then you should distill the backbone of the graph. So you should narrow it down. And as a last step, we use PageRank to determine the most important sentences. Why? Because based on the most important sentences, we made our summarizer. So as a result, here you can see the first 3 most important sentences of War and Peace. Of course, it's up to you. It's up to your settings if you would like to know the first 100 most important sentences of the text. If you would like to build a summarizer with 2,000 sentences, then you can have these settings. So if you read these sentences, you can see some keywords like Prince Andrew or Hussars. So you can get some bits and pieces of the whole novel. So you will know some details of the novel, like it doesn't take in the 21st century, because you can be quite sure that Hussars and Prince Andrew didn't live or they don't live in our age. So I'm really sure that you can get more out of the text than what Woody Allen said about it with the help of our summarizer. So much about text. Now let's turn to images. So let's see how to build similarity graphs of images. In this project, we were interested in the prototypes of women, not the prototypes of women in general, but the prototypes of women in American advertisements and their connections, so how these prototypes are connected. The source of the data, the source of the images was the advertising archive. We used the keyword women's, so the possessive, as a search word, like women's fashion, women's humor, women's anything. And we narrowed down our search to the US because we wanted to know the prototype of women in America between the 1890s and the 2010s. And we scraped thousands of images with our own scraper. So that's how we got our own data. And out of these data, our main aim was to build the graph itself. So each image was represented as a vector. And again, the basic idea is that the more the images are similar, the closer they are. So that's how we can see the relationship of the images. Let's see the steps. Again, let's be more practical. So first we vectorize the images using ResNet 18. The tool itself was image-to-vec PyTorch. We made a similarity graph out of the vectors. Again, it was a huge data, so that's why we needed to narrow it down with distilling its backbone. And finally, to order the images to see their relationship, we used PageRank. I'm not sure whether you could see the images themselves in this graph, but this was the result. I can show you a smaller part of the graph. You can see the connections here, and what was really important and interesting for me as an analyst is that the images that are connected belong to the same cluster, because in this content analysis project, we built a clusterizer. So we first clustered all the images. We built 7 clusters, and it was really interesting to find in the graph that those images were connected that belong to the same clusters. So that's why I told you at the very beginning that these methods can be used. I mean, graph building can be used as a complementary method for other methods, like for clustering tasks. So as an analyst, you can use graph analysis not only as an illustrative method, but also as an analysis, as a method for analysis. So it's time to summarize what I've said so far. You could see that graph theory and similarity graphs themselves can be understood as a single method for making your data more understandable. You can get a deeper insight into your data. You can compare any elements and features of your data, like in the case of images, we compared different prototypes of women with this feature, and it can be applied for multiple modalities like text and images, for example, and various content analysis tasks can be applied with the help of graph theory, like summarizing a text or just analyze images. Finally, I generalized the workflow for you. So this is a workflow. These are the 4 steps that you can use for any kind of data. So for text and images or anything, you should build, as a first step, you should build vectors out of your data. For this, you should use a pre-trained model like image-to-vec PyTorch or sentence transformers or anything. As a second step, you should build your similarity graph itself out of vectors, out of the vectors that you got based on the Euclidean distance. As a third step, I would always recommend you to do backbone filtering, because in this way you can get rid of the noise and you can get all the informative edges. There is a really good paper on this topic for which I gave you the source, and also you can read here the code for backbone filtering. And finally, you shouldn't forget about centrality measures, because they with the help of the centrality measures, you can order the nodes based on their relationship. So much about content analysis with the help of similarity graphs. If you liked this presentation, then I would recommend you to follow us. You can reach us via GitHub or Twitter, or we have our own webpage where you can read hot topics of NLP and AI in our blog. In our recent blog post, we wrote about similarity graphs themselves. Thank you.